You ever stop to think about what's going on behind the scenes of your favorite apps? Well, we're going to dive into the hidden blueprints that power the massive, complex applications that we all use every single day.
So let's kick things off with a huge question. How in the world do massive apps, think Netflix, Amazon, your banking app, handle millions of people using them all at once without just falling over? What's the secret sauce that lets these giant systems run so smoothly?
Well, the answer is something called architectural patterns. And you can really just think of them as proven, time-tested blueprints for building software. They're not the actual code itself, but they're the plan, the set of rules and best practices developers follow to build things that are reliable and can scale up. To make this all feel real, let's imagine we're building a brand new travel booking app, right from scratch. We need a plan to get started, right? So let's begin with the most straightforward approach there is. We're going to start with what's called a monolith. The name kind of gives it away, doesn't it? It's one big thing, and its main advantage is simplicity. Everything, the flight booking, the hotel search, the payments, user accounts, it's all bundled together into one single code base. This is fantastic for getting something out the door quickly, what we call a minimum viable product, or MVP.
And hey, it works. Our app is a hit. But you know what happens next. As we add more features, as more developers join the team, that single codebase starts to get, well, messy. It becomes this tangled web where everything's connected to everything else. It's a real headache to manage and even harder to update. It's time to bring some order to the chaos.
This right here is the first major growing pain. The code becomes tightly coupled. And what that really means is that the part that handles what you see on the screen is all mixed up with the part that processes your payment, which is mixed up with the part that talks to the database. If you change one small thing over here, you might accidentally break something completely unrelated over there. It's super risky.
So to fix this mess, we need to separate these things out. And the layered pattern does exactly that. Think of it like slicing a cake horizontally into distinct layers. You've got the UI layer on top, that's everything the user sees and interacts with. In the middle is the business logic layer. That's the brains of the operation, all the rules for making a booking. And at the bottom, the data access layer, whose only job is to talk to the database. Now, each part can be worked on independently. So much cleaner.
Okay, sticking with that same idea of separation, there's another incredibly popular pattern for organizing your code, especially in web applications. You've probably heard of this one. It's called Model View Controller, or MVC for short.
So MVC splits the app into three main jobs. The model is all about the data, things like hotel availability. The view is simply what you see, the user interface, like that booking page. And the controller is like the traffic cop in the middle. It handles your request to book a room, tells the model to update its data, and then tells the view to show you that confirmation page. It just keeps everything neat and tidy.
All right, let's fast forward. Our app is now a global success. We've got millions of users. But now our nicely organized monolith has become a victim of its own success. It is just huge. And to make one tiny little change, we have to redeploy the entire application. That's slow, it's risky, and at this scale, it's just not going to work anymore. We need a totally new blueprint. The solution? We have to break it apart. We're going to move from the monolith, one giant application, to what are called microservices, which are basically just many small, independent services. This is a complete game changer because now, instead of updating the whole app at once, we can just update one tiny piece at a time.
And that right there is the microservices pattern. Our travel app isn't one big beast anymore. Now it's a collection of tiny, focused services that all work together. We have a booking service, a completely separate payment service, and a separate notification service. The real beauty here is that the payments team can update their service all day long without ever having to worry about touching the booking service. It's a whole new world of freedom.
Now, once we've embraced this world of separate services, it opens the door to some incredibly efficient and modern ways of doing things. The game has changed completely, and we can start using some really powerful patterns.
For instance, take serverless architecture. Think about a simple task like sending a confirmation email. Why would we need a server running 24/7 just waiting for a booking to happen? With serverless, a tiny piece of code, a function, just spins up when it's needed, sends the email, and then shuts right back down. It's incredibly cost-effective and way more efficient.
Or how about an event-driven system? This is really cool. Instead of services directly calling each other, they just react to events. So when you book a flight, the booking service doesn't tell the payment service what to do. It just kind of shouts out, "Hey, a booking was made." Then, the payment service hears that event and springs into action. The notification service hears it too and sends you an email. It makes the system super flexible and really responsive.
So, okay, we've got all these patterns now. Monolith, layered, MVC, microservices, serverless. So which one is the best? You can probably guess the answer. There is no single best one. It's a trick question.
It's all about choosing the right tool for the job, you know? If you're starting a small project or an MVP, a monolith is perfect. If you're building a huge, complex system with multiple teams, microservices is your answer. And if you need to handle unpredictable, real-time stuff, serverless or event-driven patterns are a fantastic fit.
The main takeaway is this: the right blueprint depends entirely on the size, complexity, and goals of your project. It's all about deeply understanding the problem you're trying to solve first.
So, as we wrap up, I'll leave you with this to chew on. Think about the systems you use or work with every day. What blueprint do you think they're built on? And more importantly, as things change and grow, is that architecture ready for the challenge that's coming next? Something to think about.